All right, so this is a problem, number 9, I believe. Don't quote me on that. I'm not sure if it's number 9. I don't know. It's late. It's a Friday. This is a problem, again, on parallel lines. We're given the situation where if L is parallel to M, so I have L and M, so I know that these two are parallel, so I want to mark that on my graph. If L and M are parallel, and line J and K are parallel, so I'm going to mark these are parallel, but I'm going to use 2 marks here because I don't want to say that they're all parallel to each other. Anyway, I'm going to mark these with 2 arrows here because I want to differentiate. I don't want to say that these, if I mark them with 1 arrow, we might confuse that and say that, oh, these 2 are parallel also with these ones. But we can see clearly that that's not true. Okay? So I'm going to, now I've marked which lines are parallel, so I can start working on my problem. And I know that I'm looking for y, so until I find y, I'm not going to be happy. So I need to find y. So y equals something. Okay? What I'm going to do here is start off with an equation that I think I know how to do. I'm going to look at what should be obvious. Eventually, maybe by now you are starting to see this. Is that these 2 angles are what kind of angles? So you should be thinking to yourself, are they corresponding? No, they're not. This would be the corresponding angle to that one. Are they alternate interior? No. This one would be that. They're not alternate exterior because they're still on the same side. Oh, they're on the same side. They're same side interior angles, actually, right here. Okay? So these are same side interior angles, which means they should add up to 180. So I'm just going to write that down. Now that I've said that, I'm going to write that down and start with my equation. So I know that 5x, one angle right here, 5x plus the other angle, plus the other same side interior angle, plus 7x, plus 24. I know that these are going to add up to 180. Okay? Now I'm just going to start combining like terms like we do. 5x plus 7x is 12x, plus 24 equals 180. I'm going to subtract 24 from both sides. That gives me 156. And now I'm going to divide 156 by 12, which should give me x equals 13. Okay, so I found x, which is not really my end point because I still haven't found y, but it's a good start. So now that I know that x equals 13, I'm going to plug that back into my diagram here. I'm going to say that 5 times x, or 5 times 13, is going to be, what is that, 65. So this is now an angle of measure 65 degrees. And I can plug x into this equation. That would give me 91 plus 24, should give me 115. And if we want to double check my math right there, which you can always do, you should always double check me, is that these 2 should now add up to 180. If you do 65 plus 115, you will find that they do actually add up to 180. So we are in a good spot right now, okay? But now we need to find this angle over here. And this might be a little bit of a jump for you guys. So I have 2 parallel lines here. So I found these 2, and now I look at this and I'm like, it's pretty far away from all these other ones. But what we need to see here is that there are 2 parallel lines here. These 2 lines are parallel too. So now these are going to become the transversals, and these are the 2 parallel lines we're going to look at. So if I'm looking at this, I know that this angle and this angle right here are corresponding angles. So these are corresponding angles right here. Because these 2 lines are parallel, there's a transversal, these are corresponding angles. Okay? So I know that this corresponding angles are congruent. I know that that's 115 degrees. Okay? Now, if we do that same process again, that same line of thinking, I see that this angle and this angle are corresponding. That means that this angle and this angle are equal to each other. They're congruent. And that means logically that actually this one is congruent to that one, which we can kind of see by the way that we've drawn it, that they look the same, but now we have proof that they're the same, because this angle is corresponding to that one, this one's corresponding to that one, so we know that they are supposed to be equal to each other. So what we're going to do here is, now that I know that 115 and 6y plus 7 are equal to each other, they're congruent to each other, these 2 angles, I'm just going to write that down. So I know 115 is congruent to or equal to 6y plus 7. I'm going to simplify for y. I'm going to subtract 7 from both sides. This gives me 108 equals 6y. I'm going to get y by itself, dividing by 6, and I'm going to have to do some math to do that, and it should be 18 equals y. Check me on your calculator, obviously, but I think that's correct. 18 equals y, so I found the variable here, and since it was looking for y, I'm done. I found it. Y equals 18, we're good. So what this problem did was ask you to see a same side interior angle here, and then to see two steps of corresponding angles, right here, and then to right here. Another way you could have done it was to see that this angle right here, 65 degrees, this angle has to be 115 degrees, either by supplementary angles or there's a corresponding angle here, and you could see that this also is corresponding. Okay, so there's multiple ways you can do these problems. If you wanted to do a different way, you can certainly try that, and it's by all means not the only way that I showed is necessarily the right way. There are multiple ways to do it. So this is this problem. This was number 9. We're going to do one more, number 10, and then we'll be done, and I can go home and eat